Hey everybody, so for today's examples, I think we are going to take a look at a couple of different things. We're going to look at an example from the homework assignment that either you or one of your peers has requested. And then also we'll take a look at one of the five free response questions that I asked you to take a look at. We'll look at number 54. I had the choice of 52 or 54. Those are the ones that were asked about. And I think if we can do number 54, we should be able to do number 52. And then as for the free response question, I chose the 2018 version for no real particular reason, except I thought it contained some good stuff. So let's take a look. So the idea on something like number 54 is they want the integral from 0 to 0.5 of x squared times e to the negative x squared dx. And this is one of those integrals that we don't have a way of just anti-differentiating. So to evaluate this integral, we're going to have to use power series. They want us to do this to an error of less than 0.001%, which I guess once we get into it, we'll talk about how we can figure out that we are within that amount. So the way this one starts is the way that many of these problems start is let's take a series that we know, that we're familiar with, and manipulate it into this series that we can then anti-differentiate. So I don't know where else to go except of the series we know, sine of x, cosine of x, 1 over 1 minus x, inverse tangent of x. The only one that I really think makes sense is e to the x, which is 1 plus x squared over 2 plus x cubed over 3 factorial plus x to the fourth over 4 factorial. And I'm not sure how many terms it's going to take before we have our answer, so I'll go with ellipses at that point and we'll see where this takes us. So if that is e to the x, e to the negative x squared means we're just going to replace x with a negative x squared. So this is 1 plus negative x squared plus, let's see, negative x squared is positive x to the fourth, negative x to the third. Ooh, I'm second guessing myself. Let's see. This is a negative x squared. This is a negative to the third power. Let's go with negative x to the sixth over 3 factorial plus, let's see, negative x squared to the fourth power would be positive. That'll be a positive x to the eighth over 4 factorial plus we'll have a negative to an odd power. That'll be a negative x to the 10th over 5 factorial, etc. We'll see where that goes from there. And if that is what e to the negative x squared looks like, then x squared times that, we'll just multiply the whole thing by x squared times e to the negative x squared is, and I'll just multiply each of these terms one by x squared. This will be x squared. I'm going to get rid of the plus a negative and just make that minus. This is x to the fourth now that I've multiplied by x squared. This is plus x to the sixth over 2 minus x to the eighth over 3 factorial plus x to the 10th, that's a 10 over 4 factorial minus x to the 12th over 5 factorial plus some stuff. Now, as much as we don't know how to take an antiderivative of something that looks like this, we do know how to take an antiderivative of something that looks like this. So our integral from 0 to 0.5 of that stuff will be, and I'm not sure on notation here, honestly, if this is technically correct for me to say, but I do know that it's going to lead to the right answer. It's going to be the integral from 0 to 0.5 of the stuff that we found, x squared minus x to the fourth plus x to the sixth over 2. And I'm not sure how many terms of this it's going to take, but based on the experience that I have with problems like this, I'm going to guess that this is probably about as far as we need to go to get a correct answer, but I guess we will see once we start plugging some of this stuff into our calculator. And here's the weird part. I've got an integral of something with ellipses on the end. Dot, dot, dot is not something that we usually put inside of an integral, but like I said, I know it's going to lead us to the right answer. So the integral of this stuff, this is something I can take an antiderivative of. Let's see, the antiderivative of x squared is x to the third over 3. Antiderivative of x to the fourth is x to the fifth over 5. Antiderivative of x to the sixth is x to the seventh over 7 times 2 minus antiderivative of x to the eighth over 3 factorial, x to the ninth over 9 times, let's see, 9 times 6 is 54. Boy, I'm guessing we probably have enough terms by now, but let's just do one more just to be safe. This will be x to the 11th over, let's see, 11 times 24, 264. We can talk about tips and tricks for multiplying by 11 some other time. Evaluated from 0 to 0.5. Of course, when we plug 0 into this, we're just going to get a whole bunch of 0, and I'm guessing when we plug 0.5 into this, this is going to be a term that's going to be smaller than that error that they asked for in the first place, 0.001. But let's find out. We're going to plug in 0.5 to the third over 3 minus 0.5 to the fifth over 5 plus 0.5 to the seventh. Yeah, I am thinking that this is definitely going to be a number that is small enough. Oops, sorry, that is minus 0.5 to the ninth over 54. But just to be safe, we'll do one more, plus 0.5 to the 11th. That's going to be a very small number, divided by 264. Of course, it's going to be very, very, very much smaller, plus a whole bunch of stuff. And then the bottom side of that limit minus a whole bunch of 0. So we'll take a look at that. I'm going to plug this into my calculator. While I'm plugging this into my calculator, my son Luke is over here. Luke, do you have something that you want to ask me about?
What's 2 plus 2?
2 plus 2 is 4. Let's see what this looks like. Let's see, 0.5 to the third minus 0.5 to the fifth over 5. I'm going to do these term by term because as I do them term by term, I will be able to see if it's changing after the, let's see, third decimal place. 0.5 to the seventh over 14. Oh, that definitely changed after that term. Minus 0.5 to the ninth over 54. Ooh, that didn't change very much. 0.000558 to 0.00521. I'm just going to add a term, one more term just to be safe. Plus 0.5 to the 11th over 264. I'm pretty sure this isn't going to change after those first few terms, and I feel pretty good about that. So 0.00052. 0.00552, and those were the digits that didn't change. And because we are not changing after the third decimal place, I feel pretty good about that as an answer to this question. Hey, so at this point, I'm just going to fess up. I'm really frustrated with the process tonight because it is 11 o'clock and I'm trying to get this done for you guys, and it's giving me error messages. So I just put up a whole bunch of images, and that's not very useful. So I'm going to just try to talk through this fairly quickly. In part A, we're doing substitutions similar to what we just did in the previous problem from the homework assignment. Replace an x with an x over 3, and then multiply the whole series by x to get the series that I came up with. On part B, we're sending it through the ratio test. When you send it through the ratio test, you determine that it's somewhere between -3 and 3. And then you have to check the endpoints. Plug in -3, plug in +3 to determine which of those works. When you plug in -3, it diverges. When you plug in +3, it converges. So your interval of convergence is between -3 and 3, including 3, excluding -3. And then finally in part C, they're looking for the maximum error of the 4th degree Taylor series approximation. And for alternating series, you just plug it into the next term. So figure out what the 5th degree term is. They're looking for it at x equals 2. So you plug in 2 to the 5th degree term, which we found in part B. And when you plug it in there, I got 8/81. I haven't looked at the answer key yet, so I'm not sure if that's right. Hopefully that's right. If it's not, I don't know. We'll deal with it on Monday. But there we go. I need to be done with this for the week. Hopefully everything's going okay. We can take a look at other ones. If you have any questions that you would like to take a look at more closely, certainly let me know through email, through Google Hangouts. But on Monday, we'll probably take a closer look at some of these questions and start to get ready for the series test. Hope you guys are doing okay. Hope you guys are staying safe. I miss you, and I'll see you next week. Bye.